Hello, everyone. Thanks for joining our talk. So we are going to share the work we have done in the recent times. So basically, it's also a talk about the Volcano project. So we will focus more about the new features we are working on to accelerate the high-performance AI machine learning training. My name is Kevin Wang. Unfortunately, William didn't make it here, so I'm helping him to give this talk. Personally, my background is all about scheduling stuff. I started contributing to upstream Kubernetes back to 2015, and also a lot of sub-projects. And currently, I'm also working on the TOC to help the whole community. So today's talk is more based on my personal expertise and also as the role of maintainer.
Hello everyone, my name is Xuzheng, and you can also call me Xavier. And I'm a maintainer of the Volcano.
All right, so basically we will just cover the following parts of the talk today. A little bit background and deep dive our key features, especially the new ones for AI workloads. Yeah, and also a little bit more about scheduling stuff and the future plan. Okay, so we all know that in the recent years, the rapid growth of AI workloads become more and more, especially for the LLMs. You know that either from a scale, efficiency, or performance perspective, and more advanced the setup and the deployment requirements have been raised. However, for users, especially like the data scientists, that they don't have much background about the infrastructure sort of things, we think that simplicity is always very important thing. So it's kind of, we need to always consider exposing more the topology, like the underlying hardware thing, as well as providing a more simple way for the users to use. So based on our observation and the research, we think that there are two key trends very closely relevant to the cloud-native AI infrastructure, especially also very relevant to the work we are working on. So from the resources layer, previously we have done a lot of research and also implementation tryout in the in-node topology, like NUMA awareness, and also like the feature discovery thing. And now, and the focus and also the kind of attention extends to more inter-node topology thing, like the network topology stuff. With that, we also need to kind of think about how to better support, heterogeneous heterogeneous AI cluster from different vendor, right? From the infrastructure management layer, we know that the workload have become more and more complicated. Like for the training, more and more are doing distributed training, and also like this year, a lot of people are working on distributed inference, right? So we need to kind of find a way easier to mapping this deployment pattern of the workloads to better use the underlying infrastructure, basically better align with the underlying network topology. So let's deep dive a little bit more about Volcano key features. So actually, we have been working on this area for a quite long time. Before the name of this project Volcano was used, actually we were a sub-project called the Kubernetes in Kubernetes scheduling SIG. And during that time, we found that actually, workload awareness of scheduling is very important. It's not just the pod by pod. When you do like GAN scheduling and also like a lot of batch workloads, we found that we can really reuse a lot of middle state of the scheduling algorithms. And also we need to kind of queue a lot of workloads and also deal with the fair sharing between different users. That's why we kind of extended the scope and turned it to an standalone CNCF project. So currently Volcano is in the incubation level in CNCF, and we also have been adopted by a lot of users, and this year, last year, a lot of more and more use case were working on the training and also inference. So for Volcano, we basically support batch API like Volcano job, pod group, and also job flow like queue. And the new one we introduced is Hypernode. Hypernode is an abstraction for the underlying network topology. We will dive into deep later on. And also, we have provided a lot of ecosystem support. On the top, you can see actually the mainstream AI framework, as well as the big data and also a little bit HPC framework, computing frameworks. We all provide very good integration. Okay, so one of the most important feature I would like to introduce today is about the Hypernode abstraction and also the network topology we're scheduling. So we know that especially for the hyperscalers and a lot of large end users, they are kind of designing their own AI cluster to make more powerful, helping the training workloads, and also more like this year for distributed inference. So like I said before, there are a lot of research and investment on the in-node topology, right? And this year, last year, a lot of requirements are focusing on the inter-node topology, network topology, for example. So on the left, you can see actually like NVIDIA DGX, they have the concept called a super pod, right? Basically, a group of nodes that are connected with very high performance GPU network, we call it NVLink, NVSwitch, and also InfiniBand, and or even Rocky. And we found that actually there are also some of the AI cluster vendor, hardware solution vendor, they are trying to design similar concept, group a set of nodes together, define it as a high performance domain, and the underlying AI network, GPU network might be a little bit different in implementation, but from an abstraction layer, abstraction perspective, there are a lot of common ideas. So that's why we are thinking about we really should make this abstraction layer clear and easier for users, for schedulers, for the other part of the system to better, easier integrate. That's why we started working on the API called Hypernode. So basically, it defines a group of node that has similar performance in the, especially from the network space perspective. Actually, in real world use case, the nodes inside one of the hypernode can be just in same flavor. So we also, from the API perspective, we also actually designed this data structure to be able to be nested. So I'm not sure if my cursor is, has them. Okay. So on the bottom layer, you can see these are actual nodes, basically Kubernetes nodes. And we can, design all nodes connected to the same like the switch 0, this one level, as one of the hypernode, right? So like this node 7, node 6, they have just one hop, connecting with each other. And we also make it possible to define like the nodes connected in the by the switch 1, the second layer, as a kind of nested hypernode, make it easier for users to mapping their workload in the different layer. And in the result, it will be turn out to be multiple hypernodes and actually multiple trees in your cluster. You can actually define one of the tree from the data center network perspective as a tree, and also like the GPU network, the InfiniBand perspective. We don't have the limitation, it has to be one tree. If some of the nodes are not connected into the same GPU network, that's fine. You can just define multiple one, and when you're doing configuring your kind of scheduling preference, you can actually, use this field that we are adding to the pod group, the field network topology, and you can also define like the highest tier allowed. That means, for example, we marking it as 2. That means we only accept scheduling results with nodes in, like S5 or S4, like this. So it's easier for users to easy map a group of pods that being heavily communicated with each other. So this is for the hypernode perspective. So I'm giving just one of the example how a workload perspective requirements or can the configuration can be. So so actually, like for inference, like LWS leader work set, they also have the concept of groups, right? To group a set of pods together. And for training, we already have a job or a Volcano job. That's kind of, we think that it's a group of similar pod that can work together. We can actually map this group to tier 1 nodes, right? Basically, all the nodes connected with just one hop. And for training, we can do tensor parallelism in this among this group, and also we can do data parallelisms across these different groups. So that makes you good, clear expectation how the kind of latency between your pods would be, right, when you are really doing training. And it still gives the flexibility because the actual network configuration, also the setup, the implementation can vary according to the hardware provider you choose. So a bit more about the scheduling overworld workflow or the overworld process. So we are also currently collaborating with a lot of hardware solution provider to provide auto-discovery functionality for the different hardwares, accelerators, and also even the AI clusters, right? So users would able to use the hypernode controller together with the provider plugin to make it auto, discovery, fetching the underlying information about the real network setup, turn it to a bunch of hypernode definition, and become, the basically the trees inside the cluster. And also, we are relying this mechanism to collect the status information, especially health check between nodes through the switch. Like in the large-scale training, we always met issue some of the switch or some of the cable connection. So that gives you, flexibility to easier monitor the status. And when users create workloads, it's still just the normal process. The only thing we add is a new field called network topology, and basically the Volcano scheduler will find the best way to map this group of pods to the underlying hypernodes. Okay, so actually for the network topology aware scheduling, we have been working on for a long time. In the very beginning, we were just using labels on node. And also like in 2020, we started to working on implementing the scheduling algorithms. However, there are some limitations of the labels on node. That's why starting from last year, we are working on making it really a standalone API. So as you can see, there are a lot of advantages if we choose the API mechanism. For example, it gives more clear semantics because it's a clear API with very clear, field. However, like nodes, basically there's no kind of best practice. The node key, the label value can vary, by the different provider, right? And that also turns out when people are configuring their scheduling constraint, it can be complicated. While with the standard API, it's quite easy. You can always reuse the same topology constraint configuration for your workloads. And because of the design of the hypernode structure, the data structure, it provides the scalability of flexibility of the granularity. You can constraint, basically limit the workload scheduling, like spread across the different hypernodes that is in tier 1 or tier 2 connection. That's fine. While node labels, basically, everything you need to do it by yourself. And with the management, like lifecycle or status management, with the simple unified API, it's quite easy and clear. You can check out like which hypernode consists of which set of nodes, and also we can easily monitor the healthy status. While node labels, you need to kind of always take a look, update the node labels, and also there's nowhere to track the status and represent a healthy problem to the system. All right, so that's a little bit about the hypernode thing, and for the rest of the part, I'm handling my colleague Xuzheng to give the introduction.
Okay, next I will introduce some other features of Volcano. And the first one is the fine-grained job lifecycle management and fault recovery. In distributed AI training and high-performance computing environments, pod failures caused by hardware or software issues can disrupt the completion of a job. And Volcano, the job lifecycle management, enables the user to define events and action to handle these failures, such as restarting the entire job. And recent updates have further enhanced this capability with multi-layered restart policies. And instead of restarting the entire job, users can now choose to restart only the field pod or one task, improving the job execution efficiency. And additionally, a timeout semantics is also supported. If a pod recovers with a specified time window, the predefined action are skipped. Next, I will discuss the latest updates on GPU virtualization. Given the high cost of GPU resources and low usage, particularly in AI inference, Volcano offers vGPU functionality to enhance efficiency, supporting both vCUDA and MIG mode. And Volcano also provides a unified API for requesting fractional GPU resources, which is called vGPU memory and vGPU number, allowing multiple pods to share a single GPU card. Then I will talk the AI job scheduling in multiple cluster environment. More and more users are using multiple clusters to manage their workloads, while they use Volcano as a scheduler in a single cluster. To also use Volcano's scheduling capabilities in a multi-cluster environment, Volcano has incubated the Volcano Global subproject for multi-cluster scheduling, and including the queue priority scheduling in multi-tenant, and fair share and job priority scheduling. Beyond AI scenario scheduling and resource management, Volcano also offers additional functionalities for unified workload scheduling. Queue is a key concept in resource management. A queue can be considered as a basic unit of resource allocation, and often corresponding to different teams or departments, since departments typically need to share or reclaim resources. Flat queues are not sufficient for effectively managing resource sharing in hierarchical structures. Therefore, a more fine-grained and non-flat structure is necessary to handle the resource allocation between different departments. And this approach becomes even more critical when migrating big data from Yarn to cloud-native platforms. And a queue has three important fields: capability, which is a hard quota limit; well deserved, which means an elastic quota that can be reclaimed by other queues; and guaranteeing, which refers to reserved resource that cannot be shared. And in the latest version, Volcano introduces a resource dashboard where you can view Volcano jobs and pod groups and queues. And you can also check resource usage and key fields within HQ. And in the upcoming version, the Volcano dashboard will support the creation, deletion, and updating, and all these resources, and providing even more control and flexibility. Volcano natively supports batch job scheduling and is fully compatible with default scheduled algorithms. And this allows you to schedule both batch jobs and microservices in a unified manner. And additionally, by collocating online and offline jobs and also dynamic resource over subscription, Volcano can optimize resource utilization while ensuring that the service level objectives for online jobs are met. So next, let's discuss the future developments of Volcano. Distributed inference is a key scenario, and Volcano is integrating with the later workset API to support the GAN scheduling. And additionally, Volcano will support elastic replica settings for workloads like deployment and server side, and enabling better GAN scheduling for microservices. And for multi-tenancy scenarios, we are working on supporting different scheduling policies for different queues. We are also making improvements to descheduling features. And the support for DRA is currently in progress. And if you have any feature requests or preference regarding feature priorities, please feel free to share your comments on these issues. Since its open source release, Volcano has attracted a large number of developers and users, and it's now being used in production by over 60 organizations. We'd like to thank all the contributors and the users. And feel free to share your use cases on GitHub, and our community is open and welcome to any Volcano-related questions or requests. And you can also contribute following our contribution guidelines. And finally, you can connect with Volcano through our official website, GitHub, and Slack channel. Okay, that's all. Thank you.
So we still have a bit of time. If you have any questions, please use the microphone in the center. Yeah.
Hello. I have a question about the scheduling part. I saw for the network side using the network tier to schedule between the cross switch kind of things. But I'm wondering, like, if it goes to one, let's take NVIDIA GPU as an example, H100. Let's say, like, if you are using the one node 80 GPU NVLink situation, like, do you have any special setup for this kind of topology?
Actually, today we only define the. It's more from just the resource perspective and the status monitoring perspective. For the underlying setup, it's actually free for you to use. And we have been discussing with some of the adopters, so they have basically some of the assumption or design principles, like making the node connected to let's say tier 1 hypernode. All the performance are the same. Also the latency and bandwidth, they are the same.
Okay, I see. Yeah, because it's still a little bit different. Like if the nodes, if they connect with NVLink, they're in a much faster path there. And also, if there's a real optimization there, you may not just schedule one GPU out of this node and goes to the other. It needs a special kind of a configuration to make it work. I'm just curious, like how the scheduler side do this kind of work. Okay.
Yeah. So currently, we are more like because we are just starting this work. So currently, it's the resource allocation perspective. Like when you are doing for the workload communication, we are still thinking about what we can help to do. Yeah.
Okay. Thank you. Good presentation.
Thanks. All right, I think the time's over, so you're still welcome to reach out to us or just to join the community to share your feedback. Thank you.